Sorry for 1 minute. Okay, today we will complete the formation damage chapter and move to the matrix acidizing. Before moving on, I'd like to briefly recap what we covered yesterday. Can you see the slides?
Yes, we can see.
Yes.
Okay. So yesterday we talked about the formation damage caused by cementing and perforating, and the wash and spacers. When we prepare the well bore for the cementing, they destroy the mud cake, and the filtrate invasion goes into the reservoir, but not too much because of the limited volume of the used fluids. The more important is the cement slurry, the fluid that we inject with the cement. And here we have a high injection rates, and these slurries may be reactive to clays. So clays will be swelling and reducing permeability. There might be precipitations of calcium carbonates, calcium silicates when the cement material slurry gets into to contact with the reservoir rock minerals and the fluids. And also it is very essential fluid loss control during the cementing, because for the cementing, then if we lose the cementing fluid into the reservoir, that means our cement job will be unsuccessful without any cement sheets behind the casing, which will cause some may cause some channeling effect from the other formations into the reservoir wellbore, or inability to isolate the water breakthrough or gas casping zones. We have a perforations to bypass damage if the gauge hole drilled, and if the gauge hole, so this is the gauge hole when the hole of the well is the equal to the bit diameter, but in many unconsolidated reservoirs, the hole in the reservoir gets on off gauge, so we have a large area around the wellbore which should be cemented to provide isolation, to provide cement sheets behind the casing, the wellbore to provide wellbore stability. And in this case, some perforations becomes even not working because they cannot go through the cement sheet, and even if they go through the penetrate the cement sheet, then we have only a partial connection with the reservoir or original permeability zone, and the most part of the perforation tunnel will be in cement sheet, and behind that we have also some damaged zone as well. So the damage due to perforating should be cleaned up by the underbalance drilling or immediate flow back after the perforations to clean these debris, the crushed materials due to the perforation, and it might be acidizing used to clean those materials as well to increase the permeability around the perforation tunnel. During production, we have a fines movement, use of incompatible workover and injection fluids in organic and organic scales, pressure reduction leading to third phase involved, and well stimulation. So fines move is that when we have a water wet when we have a water wet rock, and the some fines are locked with the connate water, which is immobile, and as we go as we produce and water breaks through, these connate water and water comes into the flow. These connate water becomes a part of this flow, and these fines are starting to moving, and these fines will be blocking the narrow pore cells. So that's the fines movement. Incompatible workover and injection fluid. When we have a completion or workover, that will create a we will use some completion fluids like a brine or fresh water or whatever. Sometimes people use just the water that is available on the well side, and this graph is showing the effect of the cleanness of the water or brine that is injected through the rock volume. And here you can see, as we inject the untreated surface water, which has some solids, some dirty materials, as we inject the average, the permeability reduces suddenly, so very drastically, and we can't even inject very small amount of water. As we clean the water, you can see the drastic change in if we clean the water with the 5 micron filtration, and if we clean the water to 2 micron filtration, then this permeability, well, it reduces, but very little as we inject more and more fluid into the reservoir. So the cleanliness of the used workover and injection fluid is very important. And this is about the mechanical cleanliness. And there is also a problem of chemical compatibility. And in this chart, you can see different type of sorry. The chemical composition injection fluid, workover fluids, and you can see that the ammonium chloride fluid has the highest permeability. It doesn't change the permeability of the rock, but when we go to the 5% potassium chloride, then we have a some reduction of this permeability, and 2% is again giving additional reduction of the permeability, and the fresh water reduces again the this permeability to very low value. And even if we inject after that the fluid that didn't affect the permeability, but the permeability reduction or damage caused by these fluids are still there, and we have the same permeability as the after the injection of these fluids. So this is not helping. So the clean or better fluid does not improve the situation, but it stays at the same level. So it's not adding to damage, but the damage added by those fluids is permanent. This is some field example from Africa fields. Nubia formation, when using diesel, affected the less production loss, about 48%, whereas filtered seawater caused stoppage of the production, caused the fully damage to the well productivity, and calcium chloride damaged almost 95%. So we lost 2,400 barrels per day productivity. The scale formation, inorganic scale formation, again, it happens mostly in tubing. It's kind of due to the some pressure and temperature change in the roll bore. These are the chemical reactions and how to solve this problem with the mechanical removal, dissolve formation well facilities with injecting natrium chloride, calcium carbonate, or HCl acid with HCl acid, and or use the inhibition so the prevent the building up the scales. Solid wax, this is a wax deposition on the mostly on tubing. It happens because of the temperature change, and it is cleaned by the mechanically scraping or injecting hot oil solvents, and remedies again, inhibition, insulation, heating the tubing to prevent, to keep the production, to keep the fluid above the cloud point, so wax is not deposited. Asphalt is another amorphous bituminous solid in high heavy crude oil, and this is the difficult to dissolve. So if this is getting solid phase and aggravates into the big, relatively big solid particles, it's not reversible. So we have to either clean it with the scraper or the it is not soluble in solvents, so the mechanical removal is required. Fortunately, it is very rarely seen in the reservoir, so it can damage the well-bore tubing and well facilities or surface facilities, and it's cleaned by scraping so mechanically. Okay. Pressure reduction, we talked about the inorganic and asphalting scales. The increased formation effective stress because of the as we produce the formation effective stress is increased because of depletion of the reservoir pressure, and the formation starts failing in terms of the particle starts detaching from the matrix body, and this is causing the sand production. It might cause the compaction of producing interval, and hence the formation permeability may reduce. Also, it may reactivate fault, very short faults, but anyway, it may get some production interval throughout, or the becomes reduced permeability. And of course, as we talked, multi-phase flow effect, when the bubble flow for below the bubble point or dew point, the gas or condensate will be gas in oil reservoirs and condensate in wet gas reservoirs will be dropping out of the solution and will change the relative permeability. Stimulation during the again precipitation of acid rock reaction products, the consolidation of rock matrix when the acid dissolve the cementing material of sandstones or carbonates, and these fines start migrating, blocking the pores. Acid and crude oil contacting may create some sludge or emulsion formation, which has a high viscosity. Both has a high viscosity, and therefore again the mobility of the fluid is affected, and wettability may change, which again will create some mobility effect, and water blocks due to the as the water saturation increased. Is there any problem with the presentation, with the slides on the screen?
No, I can
No
see
problem.
Okay, Sabuhi, I think, has a problem. Okay, so acid selection is the key. We will talk about that in the next chapter. So this is how the not clean brine was used, and how the formation, sort of production was affected. We have seen workflow guidelines, fluid guidelines, what are the clean tanks, lines, pumps, minimum use of pipe top, etc., etc. And we are now going through this recognizing or diagnosing the formation damage. Is done by production logging tool. What is production logging tool? We have a we may have we use a wireline for this, going through this is the wireline unit you've seen, and it's a cable going through the lubricator, and the tool is connected to the cable, and we have a centralizers, pressure and temperature sensors. We have a casing color locator and gamma ray for the correlation, and we may have another pressure and temperature sensors, and the spinner, full bore spinner, which rotates as the fluid flow rate affected. Okay, so this is the how it shows the flow effect. So as we go through this with this tool through the reservoir, this spinner will rotate. Okay, and if there is no flow, the rotation will have a speed of running this tool through the well bore. Okay, as we get from the flowing zone, then we will have additional speed of additional incremental rotation speed of this spinner, and this will show us that this zone is contributing this amount to the total well production. And then going through the next phase zone, we will see additional incremental rotating speed, and that will tell us that this zone is also contributing. From that picture, we can see that this is almost the same contribution percentage. Maybe the upper zone is contributing a little bit more, but that is showing that as we identified this phase and perforated it, but there is no flow from this, so this is impaired. So this zone is not producing due to some reasons. Is it formation damage, or it might be that the perforation didn't work, so that is how the PLT or production logging test working. And along with this spinner recordings, we have pressure and temperature change, so we can see how the pressure gradient changed through the well bore, and temperature change, so we can identify where the gas influxing, where the oil influxing into the reservoir, is there any cross flow, etc., etc. Okay, so formation damage to prevention and removal, we have to identify first the type of the damage and the cause of it, why we have this damage, and what is the damage type. Then we have to identify the location. Where is this damage? Is it very near wellbore? Is it perforations? Is it inside the wellbore? Is it tubing? And then we have to see the production data, how this damage showed up, what we measured, what we observed through the production time, pressures, temperatures, rates, sand production, solids, any solids production, maybe some water in the product. Then the laboratory testing should be carried out using the cores, using the different chemical composition flushed through the cores to see what is the results of different compositions on this core in terms of compatibility, in terms of precipitations in terms of permeability change, etc., etc., and then using the core data with the microscope to confirm the damage type and location, and then we can go to the different types and the remedies or the what we can do with this and where is the impact, what is the impact on productivity. For example, if we have mud cake in the pay zone, so its most probable location is the formation phase, and if we don't remove it, then the impact will be moderate to severe depending on depth of the invasion, depending on the severity of invasion, and do we need surge pressure? Surge pressure is the pressure that we apply to flow back the well and remove or flow back the solids or any fluids that we that invaded into the reservoir. And what kind of flow volume or time needed for removal here? For the mud cake, we may need spurt volume. It means we flash it at very high rate with very short time to remove this mud cake, and then it is difficult with the cleanup volume, so we cannot apply it. Alternate method may be acids, soaps, enzymes to dissolve it and then flow back again. So that here is the table of different type of damage and how to prevent, and what are the most taking remedies, what can be done, and where this can be show up in the well production system. Okay. Next table is showing what the results can be. For example, mud cake in the pay zone again may have skin range between the positive plus 5 to plus 30, with 15% typical, and 15% means 7.5. Skin means reduction of the productivity by twice, so 15% it is by almost 3 times of the reduction. Okay, so if this is not in your book, these tables, I will provide these tables to you through the Teams file posts, so you have this for your preparations. Okay, so we have finished our the formation damage, and is there any questions?
Well, Ilham, I would like to ask about permeability damage, as you already talking this lecture in the beginning of the lecture, I guess. Can you clarify this term one more time? It was in the chemical compatibility slide, I guess. Compatibility. Yeah, sorry.
This one?
Yes, this one.
So here it's about how the chemical composition affects the permeability. Okay, in the first case, this is the first case with the 2% ammonium chloride composition, we have no damage or very little damage to the permeability. Okay, and then we inject into the same core or rock volume the fluid, completion fluid or workover fluid with the 5% potassium chloride. Okay, not the potassium, natrium chloride. Okay, whatever. Then we see that the permeability of the sample of the rock is degraded for some to some degree. Okay, so we have a degraded permeability because we injected 5% natrium chloride. Then we inject 2% natrium chloride, and this 2% natrium chloride affected the permeability of the rock even further. So even more reduction we observed. And this reduction is also bear the reduction due to this 5% natrium chloride. Okay, and then we inject fresh water. So fresh water has effect again on the permeability, but a little bit less effect because it is fresh water, and we talk about the chemical compatibility, chemical effect. So its chemical effect is less, but still we have reduced permeability due to the fresh water. And after that, and all these are injected into the same rock and rock volume, and then we inject again the composition which contains a 2% ammonium chloride, which didn't affect the permeability. And here you can see it does not affect the permeability, but the effect of these volumes, these fluids, permeability reduction of these fluids stays there permanently. So even if we injecting this, it does not improve the situation. Due to the permanent permeability damage, this permeability stays at low level, and you can see injection of this ammonium keeps the same permeability, so it does not affect the permeability. That's the permanent permeability. So it means the incompatible brines or fluids that we use during workover or completion will affect the permeability permanently. So changing to the better fluid does not improve the situation. Okay.
Okay.
Clear?
Yes, clear. So the damage which created by this completion fluid cannot be removed by the further action like acidizing or fracturing, yeah?
No, it can be, but depending on the damage, depending on the type of damage, severity of damage, the removal may be different. But here we are talking about injecting in a row different types of fluids and showing that this effect will stay there. Even if we improve the fluid type, this will not go back to this level. Okay, we are not talking about that if we apply some matrix acidizing, how it will change. No, we are talking about that this will permanently affect the permeability unless we do something.
Okay. Thank you. Okay. Yeah.
So therefore, initially at the first step, we inject the ammonium chloride, which does not affect, and at the end, we injecting the same fluid, which does not affect. We see that this fluid does not affect the permeability, but it does not improve the permeability as well. So the reduction effect caused by these fluids are staying there. So to remove this, we have to go for another remedy options that are cost effective, like matrix acidizing, sorry, acid wash or so. Okay.
Okay. Thank you, Ilham.
You're welcome.
May I ask a question, Ilham?
Yes, of course.
So my question is related to the PLT log. You were talking about its spinner and its speeds based on the producing zone or non-producing zone. Can you explain the working principle of this spinner again?
Okay. This is the spinner. The spinner in reality is a propeller. You have seen propeller of the how it's called, fan. Okay, do you know what's fan?
Yeah, I know. I got your point.
Okay, so it's the same thing. If you move this fan very fast through the air or through the water, this fan, even without any electricity, will start rotating, right? Fan, I mean, maybe you got wrong.
Ventilator.
Hava vurana ne değiller? Yadımdan çıkıyor.
Ventilator.
Ventilator. I saw.
Aha, ben de aynı şey düşünmüştüm.
So when you if you move this fan through water or air at very high speed, these propellers will rotate, okay, without electricity.
Okay.
Okay, so and this spinner is just like of propellers of the ventilator or fan. And when we move it, we run it into the reservoir, into the wellbore, and run it back. So if this spinner goes as here, goes through the non-producing zone, like these shales or damaged zone, it will show some speed of the spinner. This is zero line, and this is some speed of the spinner, and this speed is equivalent to the pulling out of the well velocity. So depending on how fast we run or pull out this tool out of the well, okay? Do you get that?
Yeah.
Okay. And then when we go into the flow zone, the spinner now is seeing not only the velocity of the pulling out, velocity of the cable, but also as it goes through the producing zone, it sees flow coming into the wellbore and going to the surface, going to the upward. Okay, and this flow. Now imagine that you keep your you keep your fan on your hand, and this water is flowing. It's not just you move it and you are in the river, and the water is moving towards you. Okay, will the fan propeller rotation speed increased?
Well,
Yes,
I thought
question.
that if it's come across any flow, any fluid flow, it's kind of a resistance against that. Therefore, speed should decrease rather than increasing.
Why decreasing?
Because moving through the fluid or through the liquid will be much harder, right? Or it's kind of giving resistance against.
No, we have fluid through all this wellbore. It is not that this area is empty. How this area might be empty is if we are producing from this zone. So what we are producing is still is in this wellbore as well. So it is moving through this fluid. Anyway.
So since their direction is the same, it helps.
At this point, now we are helping. We are the fluid is going is moving to the upward, right? So it will increase the speed of velocity, speed of rotation, because it's now any flow will increase the upward flow will increase the velocity of this rotation.
Yeah, so it is because we have flow in the upward direction and we are pulling out of the hole, that therefore it will help
Yes.
increase its speed, right?
Well, I got your point. Okay, it might be, but anyway. So you mean that if we move this upward, then the spinner will maybe rotating in other direction, and when the flow was when the flow comes out of the reservoir and flowing upward might be another direction of flow, and that might affect vice versa. But no, I think well, we can think about that for more detailed answer. But the principal thing is the when we get through the flowing zone, the spinner velocity will change. Okay, and it should increase, because now this flow from this zone, and it is increasing, as you can see, kind of not suddenly, but as it goes through the flowing zone, and when it is here, it is only seeing the flow from smaller part. When it's here, it's now seeing a larger part of the flow, so the effect or contribution is the increasing. And at this point, it starts seeing even more flow, therefore it's increasing even more. So every flow into the wellbore will increase the spinner velocity. Hello?
Yeah, I'm here. Yes, actually, I understood what you mean.
Okay.
Okay.
So, because again, the flow is going opposite to spinners. Okay, so it will affect. Well, in reality, it's anyway any flow of the through the spinner will increase the velocity. Okay.
Okay. Thank you for
Good.
explanation.
Teacher,
Yes.
I also have a question. It can differentiate the flow rate of the different phase zones.
Sorry. Yes, of course. This is the differentiation. You can see here, this zone is producing, contributing this much, Can you see the mouse?
Yes, yes, yes.
And this zone is contributing this much because this, up to this point, is the contribution of this zone. If the spinner would show this, if the spinner would go like this, then it would mean that this zone is also not producing, okay? Or if this zone wouldn't be producing, then the spinner would be like this.
Yes.
Okay.
I have also, it's clear. I have also one question. If
Yes,
there
please.
is two phase zone and they have flow, but there is one phase zone in the between these two phase zone, but it has not any flow.
Okay.
Can it detect it also, or?
Yes, the same principle. So, for example, we have this zone. If this one is producing, then from this point it would go like this. Okay. And then if this zone is not producing, then we will have a straight line through this zone. And then again, if the next zone is producing, this will go like this. Can you see the drawing?
Yes, yes. The constant meaning.
Sorry. Okay.
Yes, yes.
So the green line is the case that you talked about. So we have a flow from this zone. And then no flow from this zone. And then again flow from this zone. Okay. Schematically, it would look like this. Because now when this spinner went off this flowing zone, it will see the up to this point, it will see only the flow from this zone, and this flow is constant. Okay, so if there is no cross flow, then whatever flows out of this zone will flow upward into the tubing. Okay, so from this point up to this point until influx change, the spinner will see the same speed, will rotate at the same speed because it's seeing the same constant flow. Okay, and the next step when it
Welcome, Alan. We couldn't hear you.
We can't hear you.
Yaygın internetten şu olur. Müəllim çıxdı deyəsən.
Can you hear me?
Yes.
Sorry, something happened with my computer and internet connection was interrupted. I'll be rejoining with my computer in a couple of minutes, okay? Just wait on this. I rejoined this meeting through the computer with the slides. Sorry about that.
Teacher, thanks. I understand the question.
Just a second. Okay, sorry about that. Can you hear me?
Yes, we can hear you.
Yes.
Okay, so can you hear me now?
Yes, we can.
Can you hear me? Okay.
Yes.
So, any other questions? Is it clear? Is the concept of the PLT is clear?
Yes, it's clear.
Okay, then I will ask a question. When recording of the PLT can go like this. Why it would happen?
The red line, you mean red line?
Yes,
Maybe.
yes, red line.
Maybe in the zone there is a block or plug, decrease the speed of the flow.
How the plug in the middle zone can decrease the, because if there is no flow from this, will be so the and this flow is constant, and in this case it will go at the speed of.
Sorry, Alhamdulillah, we are losing your voice constantly.
Then how? Yeah. Then how this velocity can be reduced? What should happen? So the velocity of flow should, assuming that the velocity of cable is the constant. And flow will be lower. I used one word that should be a clue for this. What is crossflow? Crossflow is when you have a difference with different pressure regimes, and if this zone has may partially, depending on the pressure difference, may partially go through these perforations into this zone. Okay, and that's called cross flow. And in this case, of course, because some flow will go through this zone into this zone, the velocity of flow or volume of this flow will be less or reduced. And that is showing the cross flow that we are losing into the another zone. Okay, during the PLT, the production from the zone PLT is done during the couple hours, so it is not possible almost to have this decrease reduction of the production from this zone. It's about the Darius node. So this might be only through a cross flow. Okay. So unfortunately, we couldn't start the new topic of a matrix acidizing, but we discussed some interesting moments of formation damage. I hope it will help you to understand better the matter, and we'll start the matrix acidizing tomorrow at our tomorrow lecture. Hello?
Salman.
Is there any questions?
No, man. Not so far.
Okay. See you tomorrow.
See you tomorrow, man.
Okay.